Hello, students. My name is Dr. Abraham Ogwu, and today I'm going to be talking to you about universal laws of physics that have been found to exist in our universe. Our universe is made up of so many components, and a lot of these components are massive objects. That is, an object that has a mass is called a massive object. There have been many attempts to understand how these massive objects interact with each other. And one of the leaders in the scientific field who helped in elucidating the understanding of how objects interact with each other is Sir Isaac Newton. He formulated the laws of mechanics. Now, the beauty of this formulation is that those laws don't just apply on our own planet Earth, but the attempt by man to visit other planets, to send rockets to other planets, has also confirmed that the same laws that Sir Isaac Newton formulated about how massive objects interact are also applicable in those places as well. I would start the class by giving you the opportunity to tell me your names and if you have any familiarity with the works of Sir Isaac Newton. Once we've completed that part of the introduction, then I will do a gentle introduction to Sir Isaac Newton's universal laws. For example, Sir Isaac Newton was observing an apple falling from a tree, and he reflected so deeply about it that he came up with a law called the law of gravity, that because of the mass of the earth, it is able to exert a gravitational pull on another object, in this case the apple, but it does exert this pull on many other objects, human beings, cars, and all that. That's why the expression always says, whatever goes up must come down. These things can be propelled to go up, they will always come down because there is a force identified by Sir Isaac Newton called the force of gravitation that brings these objects back to the earth. From all the current observations by scientists, it seems as if the same principle applies in other planets in our solar system, and these other planets have an impact in determining the motion of each other. And going beyond the planet, even inside our galaxy, the interaction of the building blocks of the galaxies are also determined by this Newton's law of gravitation. And the interaction between galaxies themselves seem to be determined by Newton's laws of gravitation. It also helps us to understand how very high density objects that exist in our universe, such as the black holes, interact with massive heavenly bodies. It is quite interesting that a scientist can make an observation on planet Earth about how an apple falls to the surface of the earth and be able to deduce a law, a behavior that spans the whole universe. This is actually the beauty of physics, the beauty of science, and the laws of nature as encoded within scientific rules. So this is meant to be a gentle introduction to our appreciation of the fact that there are certain laws of nature that are the same all over the universe, and such laws are said to be invariant. So in this lecture, I have tried to communicate to my students in a very simplified way how observations made on the earth can be used to deduce expected observations in other heavenly bodies that are far, far away from the earth. The students generally want to have an appreciation of how the knowledge they are going to acquire is applicable to the world in which they live. So this lecture is an opener to that. It's a hook that gets the students excited about what is to come before they are now presented with rigorous scientific principles and rigorous mathematical analysis. So I am doing this as a way to ensure that the students' interest is sparked and they are able to engage with the teaching process. During this class, I would be giving the students the opportunity to ask questions as I present the law of universal gravitation to them, propounded by Sir Isaac Newton, which has been found to be invariant from all human observations of massive objects on our planet Earth. So this is my gentle introduction to the subject, using techniques like the hook to get the students interested in the process. The teaching itself is based on the principle of objectivism, where the students are presented with non-scientific facts, and the duty of the student is to try to understand and analyze how these facts fit together. It doesn't give them the opportunity to build up their own theories or hypotheses at this stage, but it helps them to learn well-established facts and to have the opportunity to observe these facts in real-time action and to learn the language for communicating how these interactions happen, which is the mathematical language. This is the essence of my micro-teaching video, where I'm trying to introduce a very important concept of universal gravitation to early stage learners in the field of physics. And the excitement for such students will now be They want to look at other parts of the universe, perhaps where this has not